Hey, yesterday I gave a speech on biohacking and I wanted to tell a little part of that to you guys today. So when I spent 20 years in the computer industry, and that is where the term hacking came from. And there's a lot of subtlety to that word when you're talking about hacking in a computer sense of the word. And there are good hacks and bad hacks. We would use it as a verb to mean we need to hack something together, which means do something quickly, or we might look at a piece of code, man, they just hack that in there. And that means they just used the most expedient way of putting some code in there that got the job done, but might not be the best thing you want for the overall ecosystem of your code. We would also use that term for the actual act of coding, and we would have what they call hackathons, which is where you try to implement something in a very short period of time with a concentrated effort. So those are all some of the definitions. But one of the other definitions that you would have is you would look at a piece of code and you would say that is an elegant hack. And what you mean by an elegant hack is that you found a new and better way to do something that is more efficient, takes less lines of code, and gets the same or better responses. And I think you have to take from all of that for the word hacking, you have to take that and realize the truth about most things in life, that there are good hacks and there are bad hacks. There are hacks that work for the short term, but not for the long term. And there are hacks that if you implement them, changes everything. And when it comes to your biology, and when we're going to start doing the same kind of things with our biology, the same thing is true. Except in computers, everything is linear. It's ones and zeros, and it's code, and one thing happens after another. And really, mostly computers are not affected by the outside environment. They're only affected by the code that you write. Well, your biology is not that way. It is a very complex system, and there are lots of variables going on inside. And not only are there lots of variables going on inside, there is also multiple sciences involved. It's not just biology. It's not just anatomy. It's also chemistry. No, there is a lot of chemistry going on in your body, needless to say. And a lot of biohacks are actually chemical. So they're drugs or supplements or something along that way. Even the food you eat is chemistry in many, many cases. But you can go even deeper into your biology, and when you get down deep enough to the cellular level, well, now you're not only talking about biology, you're not only talking about chemistry, have huge impacts on your cells, but you may also be talking about electricity. There's electricity running through your body right now. The example I like to give about how these systems go together is your nerve cells. So your nerve cells have an electrical current that translates down the length of your neurons. So down the length of your nerve cells. But then it gets to the next nerve cell, and the two nerve cells are right next to each other, but they're not touching. And what happens is that electrical impulse comes down one, it turns into a chemical process, which creates a neurotransmitter that jumps this little gap and then has a chemical process on the other side that starts another current that goes down the other neuron. So you have electricity being transmitted around, and then the cells themselves, when you start getting down to that level, there's a lot of molecules involved. There's a lot of atomic stuff going on. And now we're talking physics. Why do the cell membranes stick together? Why do all those pieces stick together? And what happens to that chemistry that's holding them all together when you when they get out of balance, not chemically, but electrically? So when their charges start changing, or when their charges are just a little out of balance, or when they match, or they're the opposite of the cell next to them. And now not only do these molecules want to stick to each other, they want to stick to the molecules in another cell. And that's what actually PEMI is working on. It is helping you to make all of those electrons have different charges for each cell, so that instead of the cells being attracted to each other like magnets, they're actually pushed away from each other. And that helps you to your cells to move more freely as they move around in your system. So your biology is not just biology. It's also chemistry, it's physics. Another form of energy that has an effect on, say, your cell membranes, for instance, is light, and specifically red light, because red light can travel through you in a way that other lights don't. And when that red light is traveling through your body and hitting those cell membranes, it's causing a change. And so all of those things are involved in your biology. And when you want to start trying to hack that, you want to start trying to find those ways that improve your performance, that stop the aging process or slow it down. When you get to wanting to do those things, that's when you start talking about biohacking. And that is what we do here at Osteostrong, here in Abilene, and at Osteostrongs all over the world. We are helping you find we are searching out, we are doing the research, we are finding the science, and we are using that to come up with the things that work. And of course, the ultimate is the Osteostrong Spectrum equipment, which was a hack in the sense, an elegant hack, in that we were looking for a solution to putting force on your bones so that your bones would grow stronger no matter what your age is, without injury. And so that's when Dr. Jaquish found a way to do that by simulating impact without the actual impact, and used multiple disciplines of your biology that are going on to make this happen. And it's elegant because not only did we find a way to put force onto your bones without damaging them, even if you have osteoporosis, but also found that you didn't have to spend an hour a day in the gym to do this. You could do it in just 10 minutes. That's the way your biology works. If you tell your bones they need to grow, they will grow, but they don't know they need to grow unless you put some force on them. And that is the basic principle behind spectrum and osteogenic loading. And then we found out, once you start doing that, you have all other kinds of side benefits. You get muscle growth as well. You get stability that you didn't have before. And if you're diabetic, you will raise your A1C as you grow more muscle in order to put more force on those bones and grow more bone. So that's why it is the ultimate biohack. Now, we offer this, and we will let you come in and try it completely for free here at Abilene's Osteostrong. And if you are interested in doing that, you are in the right place. This video has a link below that will take you to a way to sign up to come in and have a free complimentary session here in Abilene. And I'm releasing this in almost the last week of January of 2023. And we are having our grand opening ribbon cutting on Monday, January 30th, 2023 from 1 to 3 p.m. And you are invited to come and join us on that day. See the equipment, see the center, see all of our biohacks. I hope to see you there.